Alright, so we looked at points, lines, and planes. We saw what they are. How do they interact with each other? So this first question, can two points intersect? If so, what is their intersection? So let's think about that. A point is a specific, and I should say a unique, location. So if I'm looking at, say, this point right here, I'll call it C, because we can all see that one. If I pick any other point, I don't know, B. Now, these points don't move. They just stay where they are. So obviously these 2 points don't intersect each other. Well, maybe I should just pick one close to C. I don't know, how about T? Well, they're still not intersecting. And I could pick a point closer and closer and closer, but each point is its own specific location. Well, what that means is since they're not moving, you can't have one point intersecting another. That would mean that they are the same point. So each point is unique. So this means that for this question, we'll say no. No way. They cannot intersect. What is their intersection? Not applicable. There is none. Okay, so can two lines intersect? If so, what is their intersection? Okay, let's look at these 2 lines. Those look like they probably don't intersect. They could go on forever and ever. It seems like they never intersect. We call these things parallel lines. And usually in a diagram, they'll put these little extra arrows on there. So these don't. But I could have maybe something like this. And this is saying can two, meaning is it possible? So yeah, it's possible. And it looks like where they intersect each other would be a point. So yes, they can. What is their intersection? It's going to be a single point. And it's only one point because if we try to find another point of intersection, our line would have to, or one of them would have to wind around, bend. It would no longer be a straight line. And all of the lines in our class are straight lines. How about a line and a plane? So here's one way to look at this. I'm going to look at this plane, which is my flat sheet of paper, and my pen is going to be like a line. Now imagine, if you will, that the pen could just go right through that page. So this pen looks like it can intersect that plane, or that sheet of paper, but no matter which way it's angled, I'm still going to be intersecting it at only one single point. So can a line and a plane intersect? Well, yeah. What is their intersection? It will be a point. So one way you can draw that, you can think of a plane like this, and have a line doing something like this coming off of it, and then just going through. So a line intersecting a plane at a point. Do planes intersect? Okay, this is an interesting question. So I'm going to again tilt my camera so you can see. I have this plane right here, this flat sheet here, and then it could be that I have another plane sort of floating off. I know it's not perfect. It could be that they don't, where they're kind of parallel and they never meet each other. It could be, though, that this one is angled more and they meet like that. And no matter which way I tilt it, the same kind of intersection happens. If you look at all along that intersection, it's not just one single point, it's a line. So all the way from there to there is a whole line that keeps going and going and going and going. So can two planes intersect? Well, sure, yeah, they can. Their intersection is going to be a line. Alright, so how do we identify some of these different things in diagrams? Okay, so this one they want us to use the figure to answer this question, and I have these notes posted in Schoology. I did mention that in class. You can go back and kind of look at these on your own if you want to. So here I have, looks like this plane, a bunch of points, a line, and then, so they want us to name a line containing the point N. A bunch of options. I could name MO, that's line Mo, I know him. Or I could say line ON, that one's on top of its game. Or I could say MN. And as I mentioned, the ordering doesn't matter. I could say OM, NO, NM, any combination of those. So that's a line containing the point N. A plane containing the points P and M. So basically, name this plane up here. I could say PMN. I could say MOP. Can mop the floor with that one. Or I could say, I don't know, PON or NOP. Nope. A lot of possibilities. Just make sure you do not use MNO because those are collinear. Alright, last one we'll look at on this video here. Draw a graph of the description below. Okay, so this is the XY plane, and they want us to draw lines A, B, and C, D. They gave us the coordinates for those things, and they intersect at point E. Okay, so I'm going to just graph 2 points for A, B, so back 4, up 3. There's the point A. B is over 2 and down 1. And I'll just kind of eyeball it there. And that is point B. Whoops, I already drew my B right there. Just didn't see it. Okay, so A and B, and then I have C and D. So C is over 2, and then up 4. D is back 4, down 2. Alright, it says that they intersect at point E. Okay, so looks like this point is about where they intersect. Call that E. And G is coplanar with all of these, but not collinear with either line. Okay, so what that means is G is in the XY plane. It just isn't on this line. It also isn't on this one. So there are a lot of spots you can put G. You can put G here, you can put G there, here, 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 anywhere you want to, just as long as it's not on any of those lines. I'm going to pick this one. Why not? So that's good enough. So I think this will, well actually there's one more slide. We might as well just look at that one while we're here. So on the last slide here, it's asking, so for this figure, how many planes appear in the figure? Name 3 points that are collinear, and then it's asking about some coplanar. So whenever we have that word co, that means with or together. Collinear, so with the same line or together on the same line. Coplanar is going to mean in the same plane. So first question, how many planes are in this figure? So this is kind of hard to see, these three-dimensional drawings, but I have this pyramid that's on top of this plane here. I wish I had my solids with me from campus, but basically think of if I had a pyramid sitting on top of my desk here, how many planes would be showing in that? So let's count them. So we've got this bottom one. Okay. We have this one sort of on the side here. And then we have this plane that goes through D and F, so like gonna go in this direction in the back there. And then we have one more. I wish I had on my, yeah, okay, I have a marker here I could use. So I have this, and I'll do it like this direction. So this pink looking plane is on the front, and then I have this shaded one on the left, and then that back one there with those diagonal ones. Okay, so that makes 3 planes, and then I also have that bottom triangle. That's part of a plane, but then that bottom triangle is stuck inside of this larger plane. So altogether I've got 1, 2, 3, and then the bottom plane would be 4. So 4 planes altogether. Now some students look at this diagram and they think, wait, shouldn't there be 5? Because, you know, you have that triangular base there, but then you also have that larger plane. Well, the thing is that triangle's stuck inside of that plane. So we don't overcount planes, they're one in the other. So that's just going to count as 1. Here they want us to name 3 collinear points in this next question. You got a lot of options. You could say E, A, and F. Or another option, you could say G, B, and H. But you could not say like D, C, and E, because those all 3, even though they're in the same plane, they're not in the same, or on the same line. What about D, E, and A? Okay, so D, E, and A, are those coplanar? In fact, they are. So they are coplanar because if you look at this back plane, I'll copy that over here, D, E, and F. So this triangle, where I drew these lines going like this, imagine I just kind of copied and pasted it over there. A is part of that line segment, really. So yeah, these actually would be coplanar. Cool. Alright, so the rest of class is going to be a lot more fun than hearing me talk, because you're going to do an activity about looking at your own pictures and identifying points, lines, and planes.